My name is Douglas Wightman. I work for Adaptive Computing, and this session is going to be on continuous and future scheduling, focusing on two areas, reservations and preemption. Now I know last Moab.con I went very in depth on reservations. This is going to cover something different. I don't want to repeat the same subject. And then after that, we will talk about preemption. First off, reservations will cover why they make Moab the greatest. And I really do think that they make Moab the greatest. Why and how Moab uses them, how to make them work for you, and then what to avoid when you're using reservations. Then we'll talk about preemption. Does preemption work for you on your site? It doesn't work on all sites. It doesn't fit into policies, doesn't work with applications. We'll go into that. We'll talk about how Moab implements preemption. There are multiple ways of doing it, and we've chosen one way of doing it. How to configure and what to avoid with preemption as well. So, reservations. Reservations are awesome. That is how Moab achieves such high utilization on a cluster. Moab uses its patented reservation engine to ensure that the right jobs are going to the right resources at the right time. Reservations ensure that low priority workload does not interfere with high priority workload. It helps facilitate start time estimates so that users know roughly when their job is going to start. Reservations are dynamically scheduled, they're dynamically allocated. Moab will move them around all the time, it will destroy them, create them on the fly, all over the place. This is the mechanism that Moab uses to get utilization high and to ensure that the SLAs for the site are being met. So just very basic, what is a reservation? A reservation has three aspects. One is being reserved. So in most cases, it's going to be a machine, a computer. It could be the number of processors. It could be software licenses. It could be memory. It could be disk space. So that all is what is being reserved. The second, when is it reserved? What's the time frame? It could be infinite. It could be 1 minute. And then finally, the access control list. For whom is it being reserved? Can be empty, which means it's reserved for nobody. Nobody can get in there. Or it could be open. It could be open for anybody. That is basically the three aspects, the three attributes of a reservation. In a lot of ways, it works the same way as a hotel, for example. Somebody calls up, they need a reservation in a hotel. Well, you ask, when do you need it for, and you reserve the room. That's how you make sure that you're not going to get two guests in the same hotel room on the same night. Well, Moab does the same thing, uses reservations to make sure that you're not going to have two jobs on the same processors at the same time. Reservations are lots of different ways that they are created. They can be created manually in two different ways. The first, one-time reservation from the command line. That's just using the MRCC command. If you have periodic or standing reservations, those are defined in the Moab configuration file. And then there are maintenance and special projects, resource ownership type reservations. Maybe you want to ensure that this user always has access to these nodes, preferential access, and things like that. So those are reservations that administrators will create manually. But Moab also creates reservations automatically just to pack as much into the system as it possibly can. So every active job on the system has a reservation. This is done, as I mentioned before, to make sure that jobs don't run on top of each other. Idle jobs, jobs that aren't running yet, will get reservations out into the future. So Moab will map the system out into the future in basically a multi-dimensional graph. It's not just 3D because you have more resources you have more than just processors. You also have memory, you have licenses, you have all these other things that Moab has to map. So it's a multi-dimensional map going out into the future across all the resources on the system. Moab places the reservations down to ensure that the right jobs are going to the right places. Then, once the high priority jobs have been given their reservations, you've got empty slots. That's where Moab backfills. Now, because Moab uses this mechanism of giving the high priority jobs a reservation, it ensures that when a low priority job starts in front of a higher priority job, it's actually doing so without affecting that high priority job at all. Moab knows when the soonest that high priority job could start. And the soonest it could start is 10 minutes. There's just nothing that could be done to start it sooner than 10 minutes. It knows it needs, are busy, whatever. It's a big job. Can't start for 10 minutes. Well, that's 10 minutes of idle time that you're waiting. So using reservations, Moab can pack jobs in there to ensure the high priority jobs are getting on as quickly as possible, but the low priority jobs are getting on in between. So Moab creates these job reservations automatically. Creates them, destroys them all automatically without users having to do anything. They just submit their jobs. Moab places a reservation there. But there are some policies you can put into Moab to configure how Moab creates these reservations automatically for jobs. So the first is reservation policy, and the second is reservation depth. So let's talk about reservation policy. There are 3 reservation policies inside of Moab. The first is highest. This means the highest job, once a job reaches the highest position in the queue, it will get a reservation and it won't let go of it. So even if another job is submitted that ends up being higher priority, and this guy hasn't started yet, this guy still isn't going to let go of his reservation. Once you get to that top spot, your guarantee is start time. Current highest means that Moab will give a reservation to the current highest job, highest priority job. But if another job comes along and ends up being higher priority, it'll bump that guy. That guy will lose his reservation, and only the highest one will get it. The third is never. You just basically never give an idle job a reservation. Only active jobs ever get reservations. So why would you want to use each one of these? Highest. I think it really comes down to what your users are expecting. If your users are very picky, they're watching the queuing system, very demanding, in most cases you might want to use highest. Otherwise you may be getting lots of calls saying, I had a reservation and I lost it. What's going on? Why is this user higher priority than me? So by doing highest, once a job gets to that top spot, users can breathe easy. They know their job has a reservation. They can go on with their life. Current highest is useful when you have probably a lot of turnover at the top. Users aren't watching their jobs as closely, and you just want to make sure that the highest priority job is getting in there as quickly as possible. In that case, that's probably the time when you use current highest. Never, that's probably if you just wanted to increase utilization by an enormous amount. So if you think about it, if Moab is mapping out this cluster into the future, and you don't allow any idle job reservations into the future, then that means that the whole cluster is open for backfill. So at that point, instead of creating idle job reservations in the future, Moab just has this big old window that it can now fill up with jobs. So if utilization, you wanted to increase it beyond what it is, you could use the reservation policy. You can also configure how many of the top jobs will get reservations. So by default, it's 1. Only the highest priority job in the queue is going to get a reservation. And in most cases, that works out just fine. It makes it so that the backfill window is sufficiently large for Moab to continue to stuff the lower priority jobs onto the system. That works pretty well. But in a lot of cases, you may have special projects, you may have power users or whatnot, and you want to give preferential access to reservations to this group. And in that case, you can increase the reservation depth site-wide or for all jobs that make it to the top or just on a per QoS basis. So the reasons to increase reservation depth, well, if you think about it, the more reservations you've got on the system, the easier it is to predict when a job is going to start, because you've mapped further out into the future. So Moab can make smarter guesses about when a job is going to start. So if you have users who are really just pounding show start, really want to know when their jobs are going to start, increasing reservation depth can make that more accurate. Decreasing reservation depth increases system response for the most part. When there are more reservations on the system, that means Moab has more work to do. There's more scheduling to do. Every reservation requires Moab to go out, ensure exclusivity on the resources, make sure that nobody else is getting in when they shouldn't. So reservations add a lot of overhead into Moab. So if you're seeing slowness in Moab's, I think Trev covered earlier the ability to run the mdi-S command. You can see where Moab is spending its time, whether it's spending its time talking to the resource manager or it's spending its time scheduling. If you can see that Moab is spending a lot of its time scheduling and you have a high reservation depth, then you should lower it. But in all honesty, if you go in there and you look at the mdi-S command, you can see that in most cases, on most clusters, Moab spends a second or two. It's all that Moab spends scheduling every 30 seconds by default. And you want to give more reservations out so that users can check their start times and things like that. Go ahead and increase reservation depth.